The Geography of Life by Sindel Morales
Cyrus Pinjet.
and
Annie Aregyan.
Alexander Selkirk is well known for his stay at Masatierra Island, which is one of the four small islands of the San Fernandez group, and in total range from 40 square miles and 400 miles west of Chile. He is considered the real life of Robinson Crusoe and lived out his life as a castaway. When he asked to be put ashore, he only took with him clothes, bedding, a kettle, some tools, tobacco, and a Bible. At the time, Masatierra was considered uninhabited, but Selkirk found other mammals, such as goats, rats, and cats, that were introduced by earlier sailors. He spent 4.5 years of solitude before he was rescued in 1709 by a British ship and made his way back to England, where he teamed up with a writer to publish his adventures known as The Englishman. Living in a laboratory of evolutionary change. Masatierra was actually inhabited by descendants of earlier castaways, and many of Robinson Crusoe's plants, birds, and insects found their way to the island by accident thousands of years before Selkirk. In fact, many of the species are considered endemic, which means they are found nowhere else in the world. Among the island, there are 5 species of birds, 126 species of plants, a fur seal, a handful of insects that are unique and not found in other continents. Also, the island doesn't harbor a single native species of amphibian, reptile, or mammal groups that are considered common compared to other continents throughout the world. Darwin was able to observe his own experience while on his travel on HMS Beagle, where he wrote some questions about his distribution of species on oceanic islands compared to the species on continental islands. His groundwork led to a field of biogeography, which is the study of distribution of species on Earth. And he believed evolution was necessary to explain the origins and form of plants and animals, as well as their distribution across the globe. Therefore, Darwin proposed his own theory about distribution of species, and he claimed they were not made by creation but by evolution. Thanks to the development of continental drift and molecular taxonomy, it has given and provided a greater understanding as to how species have been able to distribute throughout the world, and as a result, studies have shown how continents were assembled into a supercontinent known as Pangaea that could have allowed the species to distribute, then evolve as the supercontinent shifted about, joined, and dispersed into pieces. By using the molecular clock, we can match the evolutionary relationship between known movements of continents, glaciers, and formation of land bridges. 2 different areas that have similar climates and terrains have shown to have different types of life, but with similar adaptation traits. For example, desert plants are succulents, which means they show adaptive traits such as large fleshy stems in order to store water, spines to protect themselves from predators, and small to no leaves to reduce water loss. Since these type of plants live in a climate that is intense with heat, it has evolved to withstand extreme heat by rationing out its water by having no leaves and evolving spines to ensure its survival. Though North and South America, succulents are members of the cactus family, compared to the succulents found in the desert of Asia, Australia, and Africa, known as euphorbes. The difference between both succulents can be seen by their flowers and sap, where the cacti sap is clear and watery, and the euphorbe sap is milky and bitter. Despite looking similar, they both differ in subtle ways, where each is best suited to their respective habitats. Marsupial mammals can be found in Australia, and placental mammals can be found everywhere else. One key feature that distinguishes these 2 mammals is seen in their anatomy, especially in their reproductive system. Marsupials are known for giving birth to undeveloped offspring, which finish developing in pouches. Placental have placentas that allows the young to be born in an advanced stage that doesn't require any further development besides normal growth after birth. Convergent evolution can be described when species live in similar habitats and experience environmental pressure where they evolve expressing similar adaptations despite not being related. For example, cacti and euphorbes are fundamentally different, but they show convergent traits because they both live in a similar environment that force them to evolve and obtain an adaptive combination traits. As a result, common ancestry explains why Australian marsupials share some features and placental mammals share different features. Next, speciation takes place. It is a process where each common ancestor gives rise to many descendants, and natural selection adapts each species to their environment.
Continental islands are a piece of land which at one point were part of a continent. They became an island due to separation caused by rising sea levels or moving continental plates. Some examples of continental islands include British Isles, Japan, Sri Lanka, Tasmania, Madagascar, and many more. Shown are the examples of continental islands. British Isles moved away from Europe around 300,000 years ago. Japan moved away from Eurasia around 15 million years ago. And Madagascar was moved away from Africa around 30 million years ago. Continents are located on tectonic plates. There are 7 tectonic plates. There is the Pacific Plate, North American Plate, Eurasian Plate, African Plate, Antarctic Plate, Indo-Australian Plate, and South American Plate. There are some continents or countries that can be located on 2 tectonic plates at the same time. An example of that is California, where a small portion of it is located on the Pacific Plate, and the rest of California and United States is located on the North American Plate. Why do tectonic plates move? The movement of plates is due to their placement on liquid mantle. The liquid mantle moves by convection current. There are 3 tectonic plates boundaries. Divergent, that is when 2 tectonic plates move away from each other. Transform, when 2 plates slide past each other, and convergent, when 2 plates move toward one another, colliding, resulting in one plate being submerged under the other. The figure represents the movement of plates over a period of time. If you look closely, you can notice Madagascar being separated from Africa. What explains species similarities? Continental islands were separated from the mainland with a large number of species already on them. Older continental islands that are now separated show evolutionary patterns. Some continents isolated prior to the evolution of primates and modern plants, resulting in unfilled ecological niches and allowing for new species to come about. Outcomes: movement of tectonic plates may result in vicariance. Vicariance is when a species is divided due to a geological activity or a physical barrier. Species maintain the same common ancestor. Phylogenetics is the key in investigating biogeography. Evidence is gathered from living and fossil organisms to reconstruct phylogeny. Phylogeny is evolutionary relationship among organisms. As shown in the figure, species A, B, and C, however, living on different continents or islands, all come from the main common ancestor. Madagascar. Some of the species found in Madagascar are there because they were on the same continent that separated. Over many generations, they evolved into different species. As represented in the first figure, there are different species of lemurs and lorises, but however, they all have the same ancestor that dates back to 62 million years ago. Such distribution is a result of vicariance. Second photo is of a diver in Madagascar who has discovered a treasure trove of fossils from extinct lemurs that are the size of gorillas.
Oceanic islands are islands that are raised from seafloor. Initially, they are varieties of life as growing volcanoes and coral reefs. They're never connected to a continent. They have imbalanced biotas, which means that they are missing major groups of organisms, which pattern you can see throughout planet Earth or different oceanic islands. And the life in oceanic islands is imbalanced compared to other areas in the world. Oceanic islands' temperature stays much the same year-round. However, they are wetter, cloudier, and more windswept than continents. Here we have an image of oceanic island formation, and as we can see, the island is forming from the ocean floor, coming from the ocean floor, to a volcanic island arc. Most oceanic islands rise from the sea as a result of volcanic activity on the ocean floor. They are not linked whatsoever with the continents, as we can also see on the picture. Some oceanic islands are built up around 1 or 2 volcanic vents. while others are formed by a whole series of vents. At first, these type of islands are uninhabitable, but gradually as the lava cools, they begin to support life. Some examples of oceanic islands are the Hawaiian Islands, which are located in the North Pacific Ocean, the Galapagos Archipelago, which is located in the Pacific Ocean by the equator, the San Helena Islands, which is in South Atlantic Ocean, and Juan Fernandez Islands, which is located in the Pacific Ocean. On one hand, we have the species that we find in oceanic islands, which examples are native birds, plants, reptiles, particularly in the Galapagos, and insects, and among others. And these species have the ability to have long-distance dispersals. On the other hand, the species that oceanic islands lack are native freshwater fish, amphibians, reptiles, and mammals. If an oceanic island has mammals, amphibians, freshwater fish, and reptiles, excluding the Galapagos, which were not introduced, it's because humans have introduced them, not because naturally they migrated there. When non-native species are introduced by humans, they do well on their own, so well to the point they often take over and wipe native species, which is problematic because a lot of these species become first endemic and then they become extinct, causing a decrease of biodiversity. Oceanic islands have the best colonized group of species. For example, the largest group of bird fauna dominated by finches is found in the Galapagos, a unique colony of honey creepers that descended from a single ancestral finch that arrived in Hawaii, home to dozens of flightless beetles found in San Helena, variation of sunflower family found on the Juan Fernandez Archipelago and San Helena. So these are examples of some oceanic islands, best colonizer groups